Assalamu alaikum chemistry students, how are you all? I hope you all are fine. In previous lecture, we had discussed the Rutherford atomic model and we have seen it was rejected due to some defects. Now today we will discuss Bohr atomic model proposed by a Danish physicist Niels Bohr. Let's see his atomic model was accepted or not. As in previous lecture, we had discussed that the Rutherford atomic model was based upon classical theory and it suggested that electron being a charged particle releasing energy continuously while revolving around the nucleus. Thus, if electron will release energy continuously, a time will come it loses its energy and it fall into nucleus and atom collapse or atom will destroy. So, he was failed to explain the stability of atom. In 1913, Niels Bohr not only explained the stability of an atom, but he also explained the observed line spectrum of the hydrogen atom, and he also explained why an atom gives the line spectrum. Okay, let's see what are the postulates of Bohr's atomic model. Number 1, energy level. As planets are revolving around the sun in their fixed positions, in the same way, electrons in an atom revolves around the nucleus in well-defined circular paths, and these paths are called circular orbits. Each orbit has fixed energy, so each orbit is also known as energy level. Orbit that is present near the nucleus, it has minimum energy, that is called lowest energy level. This orbit is known as lowest energy level, and the orbit which are far from the nucleus are known as higher energy levels or highest energy level. Let's see the energy levels.
Electrons revolve around the nucleus in specific orbits, and these orbits are associated with definite energies and are called shells or energy levels. These orbits or shells are represented by the letters K, L, M, N. The maximum number of electrons that can be accommodated in a particular orbit is 2n to the power of 2, where n is the number of the orbit. Thus, K shell would have 2 electrons, L shell would have 8 electrons, M shell would have 18 electrons, and N shell would have 32 electrons, and so on.
As these orbits you have studied in class 7th also. Okay, now let's move to second postulate. The second postulate is for the energy of electron. Energy of electron in an orbit is directly proportional to what? To its distance from the nucleus. Distance of electron from the nucleus. The energy of electron in orbit is directly proportional to the distance from nucleus. The electron that is near the nucleus has minimum energy, and the electron that is far from the nucleus, it has more energy. The electron that is near the nucleus, it needs more energy to move. It requires more energy to move. Why it is so? It is due to the force of attraction between positively charged nucleus and negatively charged electrons. As the electron is far from the nucleus, their force of attraction becomes weak and it has more energy as compared to electron that is present near the nucleus. The next postulates of Bohr explain the absorption and emission of energy in the form of light. When electrons are revolving around the nucleus in a fixed energy orbits, they don't radiate the energy. When they are in the orbit, they don't radiate the energy. So when electron will absorb or release the energy, let's see. Energy in the form of light is absorbed by the electron when it moves towards the higher energy level or higher energy orbit. It is just like that when we move upstairs, we need more energy. So electron also absorb the energy when it moves to higher energy orbit or upper level. Energy is released when electron jumps back to lower energy level or lower energy orbit. It is just like that when we move downstairs, we don't need more energy to come down. So the energy of the electron is released when it falls back into the lower energy level. Let's see. When an electron absorbs the energy, it moves to upper level. It will become excited and moves to upper level, and by releasing energy, it falls down back into the lower energy level. How can we find how much energy is absorbed or released? So, the next postulate helps us to calculate change in energy. The energy of the light emitted is exactly equal to the difference. Delta sign is showing the difference. This triangle is delta sign. It is for the difference. Difference between the energies of the orbits. We can calculate the change in energy by using formula delta E is equal to E2 minus E1, where delta E is equal to energy difference in between any two orbits. These two orbits may be N1 and 2, may be N3 and 4, or N4 and 5, so on. In the next postulate, we will discuss in which orbit electron revolves. To understand it, first discuss the angular momentum. What is angular momentum? Angular momentum of an orbiting object. What is orbiting? Electron is orbiting. So we are talking about the electron. Is equal to product of its mass. Its mass, whose mass? Mass of electron. And velocity. What is velocity? It is the speed of an object in a given direction. So, angular momentum of an orbiting object is equal to product of its mass and velocity and times the perpendicular distance. Perpendicular distance, small r. Distance is from nucleus to electron, as we are talking about this circle. So, orbiting distance is small r radius, distance from nucleus to electron, or simply we can say product of its mass, velocity and distance, that is mvr. So electrons will move or revolve in those orbits for which the angular momentum of an electron is integral multiple of h by 2 pi. H by 2 pi. The value of pi is 3.14, as you have studied in previous classes. What is h? H is Planck's constant with value 6.626 exponent minus 34 Js. J joule, S second. So joule second is a unit for Planck's constant. To explain the structure of an atom, Bohr used the quantum theory of radiation that was proposed by Max Planck. According to quantum theory, different atoms and molecules can emit or absorb energy. This small amount of energy can be emitted or absorbed in the form of electromagnetic radiations, which are known as quantum. The energy of the radiation absorbed or emitted is directly proportional to the frequency of the radiations. Directly proportional to the frequency of radiations. So the energy of radiation is expressed in the terms of frequency as E directly proportional to frequency, E for the energy, and this V sign is for the frequency. So by removing the sign of proportionality, we get E is equal to HV. Here H is a constant value. So E is the energy of the radiation. H is Planck's constant with value 6.626 exponent minus 34 joules second. And V is the frequency of radiation. Okay students, what do you think? All these postulates explain the complete structure of atom. Let's see.
The nucleus contains positive protons and the electrons revolving around in fixed orbitals. Is that how an atom is structured? Not really. We still have one more subatomic particle left. And what and where could it be? Let's find that out. It was around the year 1932 when a famous English physicist, Sir James Chadwick, found the third subatomic particle. He found that the particle had a mass almost equivalent to that of the proton. And what about its charge? Astonishingly, it had no charge. Yes, the particle was neutral. The particle was later named as neutron, denoted by the letter N. Thus, now we have the complete design of an atom. In the center lies the nucleus having positively charged protons and neutral neutrons, while the negatively charged electrons revolve in fixed orbitals around the nucleus.
Students, I hope you understand the structure of an atom now. Now let's discuss how to draw Bohr's model for an atom. Draw Bohr's model for chlorine atom. Z is equal to 17 and A is equal to 35. Z is for the atomic number and A is atomic mass, indicating the location of electrons, protons and neutrons. As we had discussed in previous chapter, atomic number is equal to number of protons in an atom, and a neutral atom having number of protons equal to number of electrons. So number of protons are equal to atomic number, that is 17, and number of electrons are equal to number of protons, so number of electrons are also equal to 17. How can we find number of neutrons? As we have discussed in previous chapter, number of neutrons is equal to atomic mass minus atomic number. Atomic mass is 35 and atomic number is 17. So 35 minus 17 will get the answer, number of neutrons is equal to 18. Now let's see how to draw. As we know very well, protons and neutrons are located in the nucleus. So first we will draw the nucleus. Inside the nucleus we will write proton number P is equal to 17 and neutron number N is equal to 18. Now draw the orbit where electrons are present. In which orbit how many electrons are present? As we have seen now, there are many orbits. First is K shell, that is having maximum capacity of 2 electrons. Second one is L shell, that has a capacity of maximum 8 electrons, and M shell is having 18 electrons, and so on. So in first shell there are how many electrons? 2. So we will draw 2 electrons. Now draw the second shell. In the second shell the maximum capacity of 8 electrons. So we will draw the 8 electrons. How many electrons is drawn? There are 8 plus 2, 10. But we are having 17 electrons. 10 electrons are accommodated in different shells. Now 7 electrons are left. So M shell having the capacity of 18 electrons, but we have 7 electrons. So we will draw 7 electrons in M shell. It is Bohr's model for chlorine atom. I hope if atomic number and mass number is given to you, you can draw this Bohr model for the any atom. It was all about the Bohr's atomic model Thank you.